name is Dr. Satendra Kumar, and currently I'm assistant professor in Computer Science Engineering Department at IIT PATANA. So moving towards the general announcement of this course is this will be conducted for 2-hour lecture and in online mode. So as you know that the programming and data structure, for that we need some practice in lab session also. So as this course is designed for the working professional, particularly the faculty members. So although we don't have the explicit lab session for this course, but during the class or after the class, I will share a practice problem with all of you, and I request all of you to just go through the problem statement and try to code it by yourself. So I will maintain that pace, whatever the content I will be covering in the lecture session. The concern assignment will be based upon that topics only. So next.
Hello, sir. Audio is not video.
Am I audible?
No audible, sir.
Okay. No. So for this programming and data structure, we will use the C programming for obvious reasons. I think there is a power disturbance. So are you getting my voice regularly, or is there any break in between?
Now it is okay, sir.
Sir, we are getting break.
Okay, thank you, thank you. Yeah. So this C programming. So this C programming, why we are opting this C for this course for obvious reason, because when we talk about a system programming, what exactly the system programming and other thing. Just for an example, let's say you have to write a code to write a driver for any hardware. You must have experience whenever you plug a pen drive to a Windows or maybe in another other operating system. So there is a software that get installed and we call it as a device driver. So all the programming related to device drivers or
Sorry, your voice is not audible.
okay, is this audible now?
Yes, sir.
Okay. So I was discussing like why this C programming. So C programming uh, basically used for developing an application program as well as a system program. So when we talk about the application program, so you can think of all the softwares that you are able to see. You can write in C language. Apart from that, so application program is basically used by the uh, end users to ease their work. So such programs we call it as application program. Whereas we have some system programs also that basically facilitates the system to perform some sort of task. So you can think of a uh, compiler is also a system program that basically provide a facility uh, to a system which will help them to compile a given program. So we will talk about this thing in detail, and particularly in the programming, the course content is as follows. We will talk about the variables, assignments, and expressions. How do we write the complex expression in C programming? Then we'll talk about condition and branching. Then we'll talk about iterations, where we'll talk about different type of loops, for loop, while loop, do while loop. So these are the things we'll talk about. Then we'll talk about functions also. And then we'll talk about the very important topics of C programming, is the pointers and structures. So because of that pointers only, uh, this C programming provides you a facility you can directly interact with the underlying hardware. So this is the very important concept in C programming that one should learn. Then we'll talk about some sort of data structure also. Basic data structure starting from array, linked list, stack, queue, and trees. And if time permits, definitely we will cover about a different time and space requirement of all these data structures. So these are the references. Some of you have raised me during the time when you were in offline session. So I told you that I will follow this Richie book, who's a developer, like a father for C programming. So that book we will follow. And apart from that, those who are very new to the programming, so I encourage you to go through the fourth link, which is basically the IIT Kharagpur Computer Science Department's link. So there they have mentioned have the notes and the content related to programming and data structure. So this course is a very old course, and almost in every engineering institute in India we are teaching this programming and data structure. So similarly, the Kharagpur also maintained a repository of last 10 years. So you can go through that link and you will find different kind of assignments and notes, and you can follow that also. So even the slide that I'm covering over here is also from the same link. So this the slide credit for this goes to Professor IAC Indrajit Singh Gupta. So the main creator of this slide is he only. So you can I encourage all of you to go through this link once whenever get times. So let us start with the introduction. So as I said, first we will talk about digital computers. So in any computer, uh, the main task is the computing. So it has to compute something. Otherwise, just for the computation, people like a human being move towards the computer system. So let us see what exactly we have in a computer. So whenever we talk about a computer, so there are basically in general, there are three things: a processing, input output device, and a storage. These are the three major components we have when we talk about any computers. So let us first talk about the central processing unit, where all sort of processing will be done. And the second is the input output devices. So in order to perform the computation, the computer must need some sort of input device. So through these input devices, it could be your joystick, it could be your keyboard, it could be your mouse, through which you provides input to your computer. So once the input has been provided to the uh, computer, they will perform some sort of computation. Now, based upon a requirement that processed result may need to be stored somewhere. The result may need to be stored somewhere. So, in order to store that result or indeed intermediate result, we need the memory. We need the memory. And if the result has to be displayed on the output device so that user can view these results, so for that purpose we use the output devices. So output, most common output devices is your monitor, where all sort of display we make for computers. And when coming to the main memory, so these are basically your random access memory RAM. As you can see, although it seems to be very long in this image, but nowadays we are having a very small RAM. And after that, we have this storage peripherals. So that particular peripherals or devices are also meant for storing some sort of data, but there is a difference between what we store in a main memory and what we store in a uh, secondary memory. So whenever we do some sort of computation, so the whenever we perform some sort of computation, so all the data or the code must be there in the main memory. Whereas if we need to store something permanently so that in future we will be able to fetch it and perform some modification on it. So for that purpose we use the secondary storage. So your hard disk can be seen as one of the secondary storage. So as you can see in this figure, this is nothing but the hard disk of any computer. Now, let us talk about the CPU. So, as we have discussed, all computation tasks place here in order to perform a designated task. So, as a human being, we very often we provide some sort of task to our computer to perform. It could be, uh, ranging from identifying an image recognition. Okay, or it could be identifying any if you are talking about a mechanical system, so there could be a possibility that you want to find out the fault within the system. So if let us assume that the system is automated, so the ultimate task of any computer is to find the fault in this. So ultimately we give some sort of task to the computer to perform. Now during the computation it needs some temporary storage where the computation or intermediate result can be stored. So we'll talk about the memory hierarchy. What are the different type of memory we have in computer? It's starting from the registers, then we have a cache memory, then we have a main memory, then we have a secondary storage. Okay, so all these are the different type of memory that one can think of, but the register seems to be the fastest one. Registers memory considered to be the fastest one. The reason being it is very close to your CPU, the processing unit, central processing unit. So it will take very less time to fetch the instruction from the registers and to store the intermediate results. Now, this CPU is having a circuitry to carry out the operations. So there are basically two type of operations we talk about. One is arithmetic operation, another one is the logical operation. So we'll talk more about these operations in upcoming slides. Now the last point, this is very important. So whenever a CPU has to perform some task, so that task must be understood by the CPU before its execution. So it retrieves the instruction. So this basically get done in three phases: fetch, decode, and execute. So let us talk about all these phases one by one. When we talk about the fetch, so fetch means fetching an instruction that needs to be executed from the memory. So when we talk in this context, when we say the memory, we mean the main memory, your RAM. So all the instruction before its execution must be there in the main memory. So the moment you fetch the instruction from the main memory, there might be some sort of operand on which the instruction has to operate. Just for example, let us talk about a toy example, adding two numbers. So add can be seen as the instruction because they have to perform the addition, and we know that for the addition at least we need two operands on which the operation will be performed. So the CPU will fetch the instruction as well as the operand on which this operation need to be performed. So once it is fetched, then it will be decoded. It has to understand what exactly has to be done, whether it's addition, subtraction, multiplication, comparison, and there are so many other operations. So it has to decode. So it has to decode. So decoding means converting the instruction in a machine understandable language. The machine understandable language. It's a decoding. Once the decoding is over, then we perform the operation or we execute the operation, and the result is maybe saved in the registers, or it may be in the main memory, or it may be displayed on your output devices. So this is the entire process every instruction has to go through. If you see it from a very outside perspective, that it will fetch, then decode, and then it will execute. So anyway, I'm just going through it. If you have any doubt, feel free to interrupt me in between so that we will have a discussion on it. Huh? Now let us talk about the main memory. So this main memory is a semiconductor technology. So the RAM, the random access memory, if you're using your laptop, you must be having a RAM of in the range of 4 to 32 GB, which is very generic nowadays. Okay, so that main memory is made up of semiconductor technology, and all the programs that need to be executed, you have to take that program from the secondary storage to the primary storage. Secondary storage to the primary storage. Primary storage, I mean main memory. Okay. So all this memory is measured by some unit. So the measurement is like how much data we can store in the memory. It could be this measurement is true for your main memory as well as your secondary memory. So 1K can be seen as 2 raised to 10, 1024. If it is 1 M mega, then 2 raised to 20. If it is giga, then 2 raised to 30, and so on. Tera, peta, nowadays we are talking about zeta also. So these are the unit of the data that we are going to store in our memory. So apart from your CPU we have discussed, we have talked about the main memory. Now we are talking about the input device, which is very easy to understand that all the devices through which we provide input to our system are the input devices. It could be keyboard, mouse, it could be a scanner, convince yourself through scanner, you scan the document, and finally that document get digitized, and that can be stored on our system. So scanner can also be seen as an input device. You can also think of a joystick through which we generally play the game, so that can also be considered as an input device. Similarly, we have some sort of output device also. So monitor can be one of the output device where all the things can be displayed. Printer can also be seen as an output device that will help us to get our document printed. Now coming to the storage peripherals, so we have a range of devices that we can use to store the data. So all these, the magnetic disk, optical disk, flash memory, or SSD, nowadays we are talking about magnetic tape. Anyway, it's outdated now. So all these storage peripherals comes under secondary storage, and it will store the data permanently. It will store the data permanently so that in future if you need some sort of data to be modified or used, so you can fetch it from this storage peripherals. So I will not go more into the detail of this because that is not the scope of our curriculum. But I encourage all of you to read more about this. So anyway, we all have seen this floppy disk. So that is a very small in size. Okay, nowadays it is outdated also. Very few or none of the CPU are have the support for this floppy disk, but it used to be in earlier days to store the data. Now let us see how does a computer works. So in order to have a better understanding, let us compare the computer with the calculator. Okay. So calculator is also for computing. If you remember the very first slide, I said that human tried to use the computer for the computation. So calculator also used for the computation, but how it is different? The computer is different from a calculator. So in a computer, we are provided with the storage devices. where the program can be stored. Obviously, nowadays the advanced calculators are also equipped with some sort of a storage mechanism. Okay, so even we can take example of the scientific calculator that we use in our first year BTech. So, so that calculator sometimes are equipped with a storage devices, whereas the computer are provided with a large storage devices. So this implies that in a computer we can store a very large program or data in computer that we cannot do with the calculator. So this is the main difference between the calculator and the computer. Now let us talk about what is a program. As we are talking about the subject programming and data structure, so let me first define what is a program. So technically, a program can be defined as a set of instructions for carrying out a specific task. So we are provided with a certain task, and that task can be divided into multiple doable instructions. So for example, just for a toy example, you can think of that if I give you a set of set of 10 numbers and I ask you to find the average of these 10 numbers. So what we can do? We will add all the numbers one by one. So after calculating all the numbers, after calculating the sum of all the numbers, we will divide it by the number of elements we have. So that will result in the average of that set. So what exactly we have done over here? What is our task? Task is to compute the average of a given set of numbers. Okay. So how we have achieved it? So we have first added all these numbers. So addition can be seen as one of the instructions. Anyway, we have to perform that instructions n times to add n numbers. Right? Once we have added those numbers, the another instruction could be divide the result by the number of elements. This could be the another instructions to obtain the specific task, which is nothing but to compute the average. So just program is nothing but a set of instructions for carrying out a specific task. Now, where are program being stored? So this is a very important concept that whenever we write a program, and we will write a small program today also, so that particular program first will store in a secondary memory. First we will store that program in a secondary memory, in particular in our hard disk or permanent storage. Right. So the next question arises, if you are storing our program in a secondary memory, why it is mandatory to take that program to the main memory before execution? One can always argue that if you are storing a program in a secondary memory, we can execute the program there itself. What is the point of having main memory and then taking the program again from secondary storage to primary memory? This will be an extra burden for us. So the reason behind this, the CPU is a very fast resource. CPU cycle or CPU is a very fast resource. It can perform the instructions very fast. And our hard disk are very slow in compared to our CPU. To meet the requirement of CPU, we have to introduce a faster memory. So that's why we introduce main memory in between the hard disk and your CPU, so that the time lag to decode or execute, fetch, decode or execute, the time required for these three things will get minimized. Obviously, ideally it should be zero, but convince yourself how fast your memory is irrespective of that. No, there will be some sort of time. But ideally, we are expecting a memory that will give almost a zero time to fetch, decode, and execute. So I hope the reason is clear that although we write a program, we store it in the secondary storage, but before execution, we bring it to the main memory. So now let us talk about the concept of bits and bytes. Bits and bytes. So as we are talking about a digital computer, so in digital computer, everything is a collection of zero or one, zero or one. The computer is so dumb that it is not able to understand anything apart from the sequence of zero one. Sequence of zero one. So a single bit digit, a single bit digit where we can store either 0 or 1. We call it as a bit. Single binary digit, a 0 or 1 can be seen as bit. One can combine this bit to create a nibble. So nibble is a collection of 4 bits, whereas, okay, just give me a minute. So as you said that you have some sort of experience with C programming. So what are the concepts that you know in C programming, like even in the lab, or maybe what sort of program you did?
Some sort of mathematical addition, subtraction.
Okay, okay, fine, no issue. Yeah, Ashok.
Oh, sir, actually, we have done that lab and we have seen functions programs, pointers programs, structures, unions.
Okay, structure unions. So even let's say for example, if I talk about the structures, so in a structure, can you tell me an example, a small example that you have coded in the lab?
So in structures,
sir,
we can store any student details.
Okay,
yes,
so storing your student details.
sir, actually,
Then
arrays are the one type of data type, sir. Where the structures we can store many
We can store multiple
multiple data types.
yeah. So yeah, these are the basic concept. Yeah, to know that you people are aware about those things. But just because see, in this programming, we have to give some sort of practice problem also. Anyway, so you all are working faculty and you have the experience. So I will not have like every week I will ask you to demonstrate what you have done, because I'm assuming that you will anyway will do it by yourself. Okay, so maybe in 1 or 2 weeks I may ask you to share your screen and show the code that you have done. So for that set of thing, I just wanted to have an idea. So what should be the difficulty level of the programming assignments? Okay.
Okay, sir.
And anyone who is very new to the programming, like no idea at all about the programming. Okay, so I'm assuming you people have a little idea about. Okay, there are a few guys. Okay. Hmm. Sri Lata, am I audible? Okay, I think so. Yeah, Dr. Ravi Teja. Dr. Ravi Teja.
Sir,
Yes. So you don't have idea about programming.
yes, sir. Yes, sir. I will use actually.
Okay, new to the programming. No issue, no issue. So
Sir,
basics
this
of
is
computer.
Srilata.
Sorry.
Sir, this is Srilata. Sir, I don't have any idea about programming actually.
Okay, in none of the programming language.
Yeah, no, sir.
Okay, so you are from what's your background?
Mechanical, sir.
Okay, mechanical. Okay, no issue, no issue.
Okay.
So I think we have a good mix of these things. So no issue. So I will plan to give you the assignment that I will share will have that sort of difficulty level. Don't worry. So, like as I'm going through this lecture, okay, I request all of you. So, in between, if you don't understand anything, feel free to interrupt me in between. Otherwise, it will be very difficult for me to know like where I'm lagging or like what need to be explained, again. So ideally, like if you have any doubt, feel free to interrupt me in between. No?
Sir,
So any
whatever
doubt?
you told,
Yeah. Yes, Abhijit.
sir, here the main hard disk is the secondary memory, no?
Hard disk. Hard disk is the secondary storage.
And RAM is the main memory.
RAM, they say it as a primary memory. But even the registers that we have, that registers are even closer to your CPU. So register seems to be the fastest memory in our computer. But we
In
have
case
a
of computer,
very sorry.
which is the in case of computer, which is the main memory?
Main, okay, main, don't consider this as a main word. So main memory is a RAM. We call sometimes the main memory as a RAM, random access memory. We call it as a main memory, call it as a primary memory, we call it as a RAM. So these three things are the same.
Okay.
Okay.
Yes.
Any other doubt?
No, sir. Okay.
Oh, thank you.
Thank you, sir.
So now we were discussing about the bits and bytes. So as you said that the single binary digit that one can store in computers are bit, are bit, and one can club 4 bit to create a nibble. So it is very similar. Let's say you in a distal in a decimal number system, basically we have how many digits in decimal number systems? We have 10 digits, 1 to 9 and 0. Okay, and out of these 10
No sound.
4 digits. Similarly, the collection of 2 nibble or collection of 8 bits, we call it as byte. Now there is another nomenclature that we follow is the word. So this word basically depends on the computer. So in my PC, if it is a 64-bit operating system, then it will be a 8-byte. A word is of size 8 byte. But earlier PC used to be have a 32-bit system. So over there, the word means 4 byte. 4 byte for 32-bit system and 8 bytes for 64-bit system. Now let us move to the discussion of software. So as I said, there are two categories of software. One is application software, another one is the system software. Now the application software is intended for a particular type of application. So you can think of the MS Word. So the MS Word is having a well-defined purpose that you want to write a document, you have to create a report and other things. So that to solve such kind of problem, we design a application software. Even your web browser, your Chrome, Mozilla, Edge, these are the application software. So these application software is used to solve a particular problem. So for example, why do we use this Mozilla or Chrome? So these application software help us to connect with a server. It will help us to connect with a server. So similarly, one can also think of a system software. Okay. So this system software will provide a platform to other programs to other programs. So for example, you can think of operating system. Now, when you purchase a new PC, when you purchase a new PCs, anyway, hardware, everything is provided to you with a new laptop. But if there is no operating system, then that laptop is nothing but dead. Why? Because you will not able to interact with your hardware. Then how you will able to use it? How you will able to use it? So for that purpose, we have this operating system. So operating system is a system software that basically provides an interface. Between the user and the hardware. The user and the hardware. So all sort of laptop must have an operating system. It could be a Windows operating system, it could be a Linux operating system, it could be a DOS operating system. Nowadays, anyway, if you purchase a new laptop, you will not find a DOS operating system anymore. But if you remember the older days, okay, maybe 10 years ago, so whenever you purchase a laptop, you have provided with a DOS operating system. So in summary, the operating system will provide a way so that you will able to interact with your hardwares. Now let us talk about this compiler because we will using this in our in C programming also. Okay. So as of now, anyway, in coming slides we'll discuss. Compiler is a system software that converts the program from one language to another language. From one language to another language. Why and how we'll discuss this. So as of now, you can think of that it is a system software that will basically compile a program from one language to another language. Even your device drivers also falls in the category of system software. Now let us talk about the computer language. So when we talk about a computer language, so irrespective of, don't let us not go into the computer language. Why basically we need a language? Can anyone answer why basically we need a language?
For communication.
It's for communication.
Yeah, for communication, right? And if let's say there are two entities, those who wants to communicate, if they don't understand one language, they know the language anyway. So, for example, let's say, I know Hindi, okay, but there is another guy who don't know the Hindi. He know, let's say, the Telugu. So obviously, he can also speak. I can also speak, but we both will not able to convey our ideas. Will not able to convey our ideas. So in that way, if two entity in general, if two entity has to communicate, they must understand one language. And if that language is not known to both of them, there must be a mechanism or a black box that will convert, one language into another language. So as you people have correctly pointed out, in order to communication, we need to have one language. Now, with a similar theme, we can think of that computer is one entity and we as a human being is another entity and we want to communicate. So as a human being, we know different languages, but the computer, it only understands machine language, nothing else. It only understands machine language. So what exactly the machine language is? Machine language is a collection of 0-1 sequence, nothing else. As I said, that computer is very dumb. It doesn't understand anything other than the sequence of 0-1. So for example, if I have to tell my computer to perform an addition, so to let my computer know that it has to perform the addition, there might be a case that I have to type 10110100. So which means addition. Similarly for subtraction, I have to type this. So such kind of language basically your computer understands. Now imagine a situation. If this is the case, and as a human being, we have to learn another language, a machine language, then only we will be able to communicate to with the computer. And this particular language itself seems to be very difficult to understand. Now, for addition, subtraction, think of, for every operator, for every character, if you have to remember a sequence of, you know, 8 bit, convince yourself life will be very difficult. Life will be very difficult. But as a computer, it only understands the machine language if you provide the instruction. Other than this language, your computer will not able to do anything. Okay. Now, this machine language is not portable. So let us define this term portable. So we say, a language to be a portable, if a program written in such language can run, we write a program on one machine, and if the same program can run on a different machine, the same program, then we call that the language is portable. We'll write a program in some sort of language, and if that program run on a different machine, we can say that okay, the language is portable. This machine language is not portable. It means if you write a program or code or something in machine language on one machine, the same sequence of 0 1 may not work on different machine for obvious reason. Because for addition, for my machine, ADD means 10110100. For your machine, ADD means 11110100. So obviously there is a distinction. So that's why the machine language is not portable in nature, and obviously it will be difficult to use this machine language to write a program. So then we move to the assembly language. So here life will be somewhat easy, but anyway, still we have the issue. We'll see. In assembly language, we come up with the approach. It is very difficult to remember the sequence of 8 bit for all sort of operation or all sort of symbols. So can we go with a mnemonic form of machine language? So for example, now it is difficult to remember 10110100 for addition, but as a human being, it is easy to remember ADD for addition, SUB for subtraction, DIV for division. So as a human being, somewhat it is easy to remember, right? So in assembly language, basically we go with this mnemonics corresponding to a machine language. Still, this assembly language is not portable for obvious reasons, because for addition in one language it could be ADD, another language it could be the addition, the complete word. So because of that, even the assembly language codes are not portable, Now, if you move from a machine, our computer only understands machine level language. The sequence is 0 1. And if you write some sort of program in assembly language, obviously that will not be understandable by our machine or PC. So for that purpose, we need a assembler. So assembler is nothing but a translator. Assembler is nothing but a translator program that converts your assembly language into corresponding machine language program. Now, this assembly language is also difficult to use to write a large program. Just for a example, just think of if I have to find an average of 3 numbers. So these many instructions I have to write in assembly language, where MOV stands for move, ADD stands for addition, and DIV stands for division, and MOV again stands for move. So just to find the average, you have to write these 5 statements. Whereas in C language, you will see that this particular single statement is sufficient to write a program that will result in the average of 3 numbers, X, Y, and Z. Okay. So first, in summary, we have started with machine level language, and we have argued that my machine can only understand the machine language, the sequence of 0, 1, but as a human being, it is not easy for us to write a programming machine language. Then we gradually move to assembly language, where we use some sort of mnemonic for to remember the stuff. But even in assembly language, things are not very easy to remember or to write a very large program, a very large program. So we move to a high level language. So all sort of high level language are close to the human being, or somewhat you can say all the programming languages are or high level languages are based on English like language. We'll see in order to write a program in Python or in any high level language, we use some sort of keyword that is very easy for human being to remember. Okay, so now the high level, now as of now we have discussed about three language: machine level language, then we have assembly language, then we have a high level language. Now the high level language is very close to the user or a programmer, but it is very far from the machine, because machine only understands 0, 1. So this high level language and the machine level language are the two different extreme. One is close to the machine, another one is close to the user. Right? Now, if a user write a program in high level language, it must be converted. It must be converted or translated into machine level language. Then only the machine will do the needful for us. So to convert a high level language to a machine level language, we use a software which is known as compiler. So based upon which kind of languages, sometimes we use compiler and sometimes we use interpreter also. So let us not go into the details of this. Just as a black box, you understand, in order to convert a high level language into machine level language, we need compiler. Now, these high level language are typically portable across platforms. Because the code that you write on one machine, the same code you will write on another machine. Okay, and here the compiler plays a very important role. So compiler will convert your code into a machine level language that your machine will able to understand. If you have any doubt, please ask as of now.
Hello, sir.
Yes.
Hello.
Yes.
What about the code generated for any operation in case of machine language? So how the machine understand that for the add operation this is the code?
What is the? Can you repeat your question once again?
In case of machine language, as you see, there is some code for the add, there is code for subtraction. So how the machine will understand this code that is, when we are getting this code, then we have to perform this operation.
Right. So basically, we have a well-defined mapping. For, let's say, think of a very hypothetical system where we are having a, uh, 4 digit of code. No, 4 digit of code. So let's say 000 represents addition, 001 represents your subtraction, 0010 represents the division, and so on. Right? So whenever when you write x equals to 3 plus 2, okay? So 3, how many different characters you have in this statement? X equals to 3 plus 2. They are basically 5 characters. X equals to 3 plus and 2, right? So each of these will have a well-defined number associated with, or sequence of 0 1 associated with it. Okay, so whenever your CPU fetch the instruction from the CPU. If you remember, we have discussed about fetch, decode, and execute. So during the fetch cycle, it will fetch instruction from the memory. Okay, and then during the decode part, it will able to understand that okay, this means addition, and I have to perform addition on it. Is this clear, Abhijit?
Yes, yes.
So to know more about this, okay. So those who have gone through this computer architecture or organization, okay. So things will be more clear on this. So whatever the answer I have just given to you, it is a black box type of answer. Any other question? No. Okay. Now here see, I'm just showing you how basically a high level program that we write in a high level language get converted to a executable code that we will execute. So ultimately we write a program in high level language. So for example, you must have used the Google Colab during your offline session, or any programming language. You will write a programming high level language, then it will go through this compiler. And as of now, we have just discussed that compiler is nothing but to convert the high level program into machine level or machine understandable code that machine can understand. Okay. So particularly if you see from a C language perspective, so after compilation, you will have a object code. You will have an intermediate object code. Now, along with that object code, the linker will link the library. What exactly the library is? So when we write the very first program, you will be able to understand. So as of now, you just think of along with object code, something else get added, and it will get converted to the executable code. And that executable code finally will run on your PC. Will finally run on your CPU. So we have, I'm just skipping this slide because we have already discussed about operating system, that it will make the computer easy to use. It will provide an interface between the user and the hardware. And there are different type of operating systems: Windows, Unix, Linux, and Mac. Okay, so even for a mobile phone also we have iOS or Android. So these are the different operating system we have used for our devices. So initially I planned to use the Linux operating system for solving the assignments. But anyway, as we are in an online mode, so we will use this online GDB compiler. So it's an online platform that basically provides this service. You can run your C program. On it. I will demonstrate you this today also. So now with the introduction of what is the digital computer, how basically we store our program, how it will get executed. Now slowly we are moving towards the programming concept. So there are some basic terminology one should understand before going for any program. So the first you can think of the algorithm. There are few buzzwords: algorithm, flowchart, pseudocode, and program. Let us go through this one by one. So the algorithm algorithm is a step-by-step procedure for solving a particular problem. Just for an example, you just think of that you have registered for this course, and you have traveled along back, okay, from your place to IIT Patna campus. So let us see, the problem is you must have solved, you have already solved this problem, how to reach from your place to IIT Patna, right? So what are the procedures that you have followed? You must have, booked a cab to reach to railway station or airport, and from there you might have taken either train or flight that will take you to the Patna airport or Patna railway station, and from there you must have booked a cab to reach to IIT Patna campus. So given a problem statement like how to reach from location X to IIT Patna, this is the problem, right? And we have a step-by-step procedure to solve this problem. So all those steps from your place, booking a cab and reaching to airport or railway station is step 1. Second step, the train or flight will take you to Patna, either airport or train, based upon which of the medium you have taken. Now from there, you book the cab that will take you to IIT Patna campus, the third step. Okay, and once you reach to gate number 1 of IIT Patna, from there maybe by walk or your cab itself dropped you to a particular hostel where you have stayed. So in life, not about in programming, in general life, we always solve so many problems. Okay, and in order to solve a problem, we have a step-by-step procedure that one should follow to solve it. So that step-by-step procedure is your algorithm. So now let us move to flowchart. So flowchart is again another medium through which we show or write the algorithm. So one procedure could be, one can write, book a cab from location X to railway station, board the train, and train will take you to the Patna. Then after that, you book a cab and reach to IIT Patna hostel. Another way to have the same thing is you can draw a figure or a symbol. So in flowchart, instead of writing a English like language, we try to draw some sort of symbol that will help us to understand it. So and pseudocode as its name suggests, it's not a code but very similar to the code. So all these three terms, algorithm, flowchart or pseudocode, are independent of the programming language, and it is nothing but a step-by-step procedure to solve a given problem. Why it should be independent of a programming language? Because once you know the procedure to solve any problem, you can solve it in one language, you can solve it in another programming language. It is very similar to the way we can think of. Let us now take an example that we have to make our child understand the addition to add two numbers. Okay, so once we will make them to learn how to add a number. Okay, so it can be explained in English language also. It could be explained in other language also. But the underlying concept will remain same. So that's why it is always a good practice before going to write a program. One should have a clear idea about how you will solve it. Because there is a probe, we can say, if you cannot solve it by yourself, okay, then you will not ask computer to solve it, because the computer can only do a set of instructions or execute a set of instructions, that you can provide it. If as a human being we are not aware about how to add two numbers, we cannot ask, or how we will ask the computer to add two numbers. So any algorithm, flowchart or pseudocode that we have must be independent of any programming language, and it is simply a step-by-step procedure to solve a particular problem. Now let us talk about program. So these programs are a translation of algorithm, flowchart or pseudo code into a shape that can be processed by a computer. So that particular entity we call it as a program. So this can be written in any high level language: C, C++, Java, Python. So program can be written in any high level language. Now let us have a very first look. To a C program. If you see over here, the very first line. So what we have in this line? Program to compute the area of a circle. You know how to compute the area of a circle. Given the radius, you will use the pi r square to find the area of a circle. Now what is special about this line? This particular line is between these two entities, slash star and star slash. So whatever you write between these, that will considered as a comment. So what is special about the comment? Your compiler. What is the purpose of compiler? To convert the high level language into machine level language. So whatever you write in terms of comment, your compiler will simply ignore it. Whatever you write as a comment. So the comment generally we write for our understanding. So the first line will be ignored by your compiler. It will consider blank over here. Now let us move to the second line. Here we have hash symbol, include, and then in bracket stdio.h. So this stdio.h stands for standard input output.h. Let us discuss what we have over here. Standard input output.h. This is first, we call it as a header file or library file. So these as of now you can think of, or I will come to this part. Let me first explain this. Now convince yourself, compulsory for library files. It is written with this slash. Yes, please. Yes.
Hello, sir.
Yeah.
Please explain the header file again.
Yeah. So this standard input output.h is a header file. Why we include this header file over here? I will just explain you. Okay. After explaining this main part. Now you see this part. Compulsory for library files. This is again in a comment section. So this will be ignored by your compiler. Similarly, function heading, declared variable, read radius, output to the screen. All these, whatever we are writing in terms of brown color. So this is nothing but the comments, because it is there between slash star and this thing. Now we have this mean. Mean is a function. What it is, we will come to this part also. Now over here, our goal is to find or compute the area of a circle. We know in order to compute the area of a circle, one must know the radius, because without knowing the radius, one cannot compute the area, right? So given that thought, now we will ask user that what is the radius of a circle whose area you want to calculate. So user will provide you the radius through keyboard. Well and good. Now you must have a mechanism to store that value. You cannot store the value in the air. You must have a way to store that value in your computer. So for that purpose, we are defining a variable named radius. Radius is a variable in this program that is intended to store the value of radius, whatever the user will provide you. Why we need this? Because we cannot store a value in the air. There must be a way where we can store it. Now, once the user has provided you with a radius, your next goal is what? To compute the area. Good. So once you have computed the area, the value of area must be stored somewhere. Again, with the same logic, you cannot store the area in the air. So you need to have a variable where you will store the final value. So for that purpose, we are declaring this area as a variable. Now, once you have computed the area, your goal is to print the result so that the user will able to see the result. So for that purpose, we use this function printf all in lowercase. So printf is a function that basically used to print on the console. There are different format of this. We will discuss this part. Okay, so as of now, you just think whatever you will write in printf, it will get displayed on your monitor. Similarly, whatever, if you have to take an input from the user, you have to use this scanf function. Is this clear to everyone? Scanf and printf, why we use scanf to take the input from the user and printf to print something on the console.
Yes, sir.
Right. Okay. Now, corresponding to this is printf and scanf, there will be a code associated with it. That code basically make our compiler understand that, okay, if you encounter a scanf, it means you have to take an input from the user. Now the question arises, where are such code? Similarly for printf, the compiler must understand that if it is a printf, that should go to the output device. How we will instruct the compiler? That throw whatever is there in the printf to the monitor. So all such corresponding codes are written in your header file. So that's why if one have to use this scanf and printf function in their code, they must include the standard input-output.h header file. So now let us have a more discussion on this header file or library file. It is nothing but a file where the code corresponding to the inbuilt function, I should say this as an inbuilt function, the scanf, printf, these are the inbuilt function. So the functionality of the scanf and printf are well defined in this header file, the standard input output.h. That's why it is compulsory to include this header file. Is this part clear to everyone? If you have any small doubt, please ask.
Sir,
Yeah.
in the scanf function, whenever user give the input, that
Mhm.
value will be stored in the radius variable, right, sir?
Right. Right.
And what is that ampersand symbol? Ampersand means address of operator, sir.
Right. I'm coming to that part. Don't worry. I will explain you everything. So whatever
Okay.
I have just discussed, is this part clear? Why there is a need of header file? Okay. What are the contents are there in a header file? This part is clear to everyone.
Yes, sir.
Okay. Now let us talk more about this. One question arises: how you will distinguish, or how you can say that okay, particular thing is a function. As of now, I said scanf is a function, printf is a function. I haven't said that area is also a function. So anything in general, there is a exception also. So anything that followed by a open bracket and a closing bracket. Typically in C programming, all such things are functions. So with that logic, main is also a function because it is having an opening bracket and closing bracket. Clear?
Sir, one doubt, sir.
Yeah.
Sir, can we call them as methods also, sir?
See, functions and methods both are same thing, but if you are talking about object-oriented programming, so in object-oriented programming, we call these things as method, and when we talk about a structured programming like C, we call it as a function.
Okay, sir. Okay. So that means C is not based on oops
No,
concept, right?
C is not an object-oriented programming, right? Java is an object-oriented programming.
Structured means what is different, sir?
About this, I mean the structured programming and object-oriented programming.
Yes, sir. You are saying that C is a structured programming language.
Whereas
So that
Java is an object-oriented, right? See, I will answer in this way. See, Java is object-oriented programming. So what does this mean? That in Java, everything you can see as an object. Everything you can see as an object. Okay. So for example, you know, if I let's say think about you are in front of the monitor itself. So I can think monitor as an object. So that object now will have a different attribute. It will have a size. It will have a color, right?
yes, sir.
So it is more the Java as a programming language is more towards the way we look the universe. The way we look the universe. So in a universe, we see objects. So it supports that view of that thing, Java. Whereas when we talk about a C programming, so it is a plain structured language where the set of instructions we are writing one by one, and this is also being executed one by one in a structured form. If you talk about object oriented programming, then we define a class. So in a class we have some sort of variables and some sort of method in together. Encapsulation concepts are there. Okay, so in a very naive way, you just understand that in a C, okay, things are structured and written in a statement, and we execute this statement one by one. Whereas Java, that is object-oriented programming, supports the view that a human can see the world in terms of object.
Yes, sir. So,
Any other doubt?
sir, let's say suppose I written a code for sum of two numbers in C as well as in Java, for example, sir.
Right.
So in C, you are saying that the code will be executed step by step, right, sir?
Apart from that, okay, so I missed, so I'm not going to detail of those things. See what happens whenever you are writing, in Java. Okay, so you can define a class where you can have a two variable, and you can also define a function or a method, okay, that can be operated on that set of variable. Okay, so in one packet you have operand as well as the operator or method, which is not true in C programming. You have to define the functions. I mean, you have to define the variable separately and the functions separately.
Okay. Okay, sir. Okay.
So in that sense, so actually I was about to make this statement that Java is more powerful than C, but it is again debatable. If you see from a system perspective, C is more powerful, but if you see from user perspective, then Java is more powerful as compared to C. Okay.
Yes, sir. Yes.
Okay, fine. Now let us see some other points also. So here we have this main function. So the main function, so anything that's have this opening bracket and this closing bracket typically considered as a function in C programming. So scanf is also a function, printf is also a function, and main is also a function. Main is basically a special function in C programming. Whenever you run a program, ideally it should start from here, and there could be, from the very first line. But in C programming, the execution always starts from main function. If you write your main function towards the end also, the execution will start from there itself. So main is a special function in C that you can see as an entry point of execution. Now we have this float. These are the variables, because as I said, and we have convinced that, okay, in order to store the radius, we need to have some mechanism. So we have reserved a space in a main memory. Now, what is the point of defining it as a float? Now, float is a data type. Float is a data type. So with that data type, we are conveying our compiler that in this variable we are going to store a real number. We are going to store a real number. So for example, a radius could be 30.5 centimeter. A radius could be 25.9 centimeter. So similarly, the area corresponding to this given radius can also be a real number. So all such variable can be stored in float type variable only. If I define it as an integer variable, int is a keyword, we will come to that, then you will not able to store 10.9 in an integer variable. It will only store 10. It will truncate 0.9 out of this. Now coming to this scanf. So you see, try to observe that in scanf we have two parts. First is the format specifier, %f. So this %f tells our compiler that over here we are expecting a float value. We are expecting a float value. And if a user input that number, you store at the address. So I'm not going to this. When we'll discuss about a pointer, we'll come to this. As of now, you just think of that this is the way to store the given number in your main memory. Ampersand, with the help of ampersand operator, you are being facilitated to store the number in the main memory. Whereas while computing the area, you need to only read the number. So there is no need to add ampersand over here. Only radius you can add and then it will be computed. Now can anyone tell me in printf, again we have two parts, area equals to, what is %f over here? It is very similar to this.
Format specified.
It's a format
Format
specified.
specified.
Right. So typically whatever you write in this double inverted comma, the same thing will get displayed. The same thing will get displayed on your console. But as your intention is to print some sort of value over here, so you have to specify what kind of value you want to print, and that you have to provide over here where that value is being stored. Okay, so more, I think it's a good time. So let me just use this. So I'm just sharing this in a chat. Fine. So once you will reach to this site, first you have to select a language in which you are writing your code. Are you able to see my screen?
Yes, sir.
So let me select a language C. Fine. So let me just clean all these things, not an issue. So if you remember, in the very first line, we have used this header file. Sorry. So this is the basically the header file, and hash include, the include is a keyword in C programming that basically include our standard input output.h. Now I think this thing will be more clear if I go to this part. I told you that whatever you will write in a high level language, it will get compiled and the object code will be generated corresponding to it. And in this object code, some sort of library will get added. Now convince yourself what I mean over there. So whenever you write a code over here, you are not writing the code corresponding to printf in scanner. Instead of that, you are adding this header file. So all the code corresponding to printf in scanner will now get added to your object code, and it will finally make you the final executable code. So now let me write the main function. So our goal over here, or let me change the example. Now I will take two numbers from the user as an input, and I will add those two numbers. So convince yourself how many variable I have to define. Let us assume we are dealing with an integer number only. How many variables I have to, or how many things? Okay. So convince yourself if you are going with a addition. So at least I need two variables. Let us name it as x and y. Okay. Am I audible?
Yes, sir.
Yes, sir. You are audible.
Yes, sir.
Fine. So in x, I will store my first number, in y, I will store my second number. So now I have to ask the user, please, sorry, anything to ask? Now I have to prompt the user, provide me with this value x and y. So for that purpose, I will write printf function, and in this close bracket, first I will write this double inverted quotes, and I will write a user that, okay, please enter first number and then semicolon. It's the termination of this statement. So immediately after that, user will provide me an input from the keyboard, and I have to catch that input and I have to store it in a memory. So for that purpose, I will use scanf, and again see how I'm writing scanf. %d, a format specifier, comma, and I have to store over x. Clear? So let me just again print what exactly is there in x. So x equals to some number that I am storing in variable x. Let me just run this small code for you. See what is happening over here. Ignore this warning as of now. Okay, or let me just let me just write a void over here. I will explain you what is void. So see, I have run this code with this run. So what it is prompting to me? Please enter first number. So it means we have executed this statement. So let me enter the number 88. Okay. So the moment now I press enter, it gets stored over here x, and I am printing the same value over here. So that's why it is showing x equals to 88. Is this clear to everyone? Is this clear to everyone?
Yes, sir.
Yes, sir. Yes.
Yes, sir. Yes, sir. Yes,
Sir,
sir.
in the scanf statement for x, if we don't give any ampersand, what will happen, sir?
Okay, yeah, so you are saying that you have compiled, but you are not giving any input to the user, to the program, right?
In the scanf statement, sir, before x, that if the ampersand is not available, then what is the meaning of that line, sir?
No. So ultimately, what will happen? See, as I said, when we discuss about a pointer, then it will be easy for you to understand. So if you are writing x, so ultimately in scanf, after the format specifier, you have to provide a memory location.
Okay.
You have to provide a memory location where the value gets stored, and through %x only you will able to fetch the memory address. If you provide x, okay, so it will consider this as an address, but actually it is not an address, then it will be an error.
Okay. Okay. Sir. But in printf, we need not to add that ampersand.
No. So because see, the reason is through scanf we are writing something in a memory.
Okay, sir.
Whereas in printf we are only reading it. So that's why %. So as a beginner, most of you will have initially this issue that where to write %, and not. So that's why thank you for asking this question. I'm explicitly mentioning whenever we use a variable name in scanf, one should use the %, whereas in printf % is not required.
Okay, sir.
So now let us extend this program. Let me just use again a printf statement to take another number. So I will write, please enter second number. Now I will use this kind of, please mute yourself if %d And with the similar logic, now I am going to store my second number in 1. Okay, and let us see, are we able to do it successfully? So I will print the another statement. Y is this Y. Okay, so let me just run this program. First number, let's say 60. Then it is asking me the second number. So let me give the 40 as the second number. Then it is printing, it says 60. The first input is got stored at this location, and the second input got stored at this location. Right? Now, what I am doing over here,
Commenting 2 lines.
commenting, right?
Sir, one question.
There is another way to comment. You can write double slash. So this will comment you. This will comment the given line itself.
Sir, I have a question.
Yeah, just give me a minute. Huh? Yes, Ajay. Mm-hmm. Yeah, sorry. Yeah. Someone was having a doubt. Please ask.
Sir, in case of PPT, you write there ampersand M, F,
Ampersand.
and here ampersand
Okay.
D.
Okay.
So,
No. Yeah. So see, here I am using this integer variable, not the float one. If I use the float variable, so for float the format specifier is %f, and for integer the format specifier is %d.
okay, sir.
Okay, so let us try that also. If I input 89.78 and see what happened. So my program got terminated because at line number 6 it was expecting an integer variable, but I have provided a float variable, so it will not accept that input and it has terminated. Right?
Okay, sir.
Okay. Yeah. So now our goal is to add these two numbers. So anyway, one can write x plus y to add these two numbers, but we have to store it somewhere. So for that purpose, I have to define another variable, and the sum of two integer number is always an integer. So it will be sum equals to x plus y. Is the line number 9 is clear to everyone?
Yes, sir.
Okay. Now, in the line number 10, my goal is to display the result as the sum of two number is the final result. So what should I write? Printf bracket, and within a bracket double quotes, I will write sum of given two numbers is, I want to put some value over here. So as I want to put some value, I will write a format specifier that tells my compiler that over here, and I will provide you one value that you have to add over here. And that value you have to provide immediately after putting this comma. And that value where we have stored? We have stored in sum. Is the line number 10 is clear?
Yes, sir.
Yes.
Yes, sir.
See the difference between line number 10, the printf used in line number 10, 7 and 5.
Yes, sir. The sum variable will come in the place of %d.
%d, exactly. So now let us run this code. So let me have 85, the first number, and 40 as second number. So the sum of given two number is 99, that we are able to print. Is this making sense to you?
Yes, sir.
Sir, excuse me.
So let's say now I want to let me modify with the statement.
Hello?
The same code I want to change so that I will able to find the average of these two numbers.
Hello?
Yes.
Sir, whenever we are writing anything in between double quotes, it is a comment, right?
No. For comments, either we use this slash, double slash, or slash star.
Statement, double quotes. Whenever
String,
we are writing
string.
it's a string.
It's a string. We will come to that part. Huh? String.
Then
character.
how this %d will be acting to some
How this %d?
printf sum of given two numbers is %d. It is in between the double quotes.
It is in between the double quote. So, but over here, as you are not writing, so let me just simply write, SUN star star. So it will not do anything. It will simply print that part. It will not do. It will simply. Let me even give the result. 85, 40, some star star. So it is simply copied and pasted it. But if you want to print some value with this, then you have to give a format specifier that okay, I will give you a number that you have to print in place of %d. So now the next question arises, where is that value? So that value you will provide with a variable name where you have stored it. Okay.
Sir, one question.
Yes, please.
Sir, in case of sum equal to x plus y, here
Sum
the
equal-
memory allocation is not by %d.
You can simply write x plus y. That will also work. Not an issue.
But previously by scanf we are allocated the memory
See,
by using
for
the ampersand.
for some we are not doing the scanf. So it's a good observation. Let me directly write over here. What happened? Fine. So in this case, basically, we have not allocated the space to store the intermediate result. We have simply thrown the result to the console itself. So this is also doable. Okay. Now the last
The result is not stored anywhere, no?
The result is not.
Not stored. That's why we are not using the ampersand.
Yes.
Okay.
Now please help me to modify this code to print the average. What are the changes I have to make now?
In the place of sum, AVG is equal to x plus y by 2.
By 2, right. So I will simply by 2.
And in the
And
filter,
here,
in 10th line, we replace sum with ABG.
yes. So will this work? Let's see. It's working, right?
Yes, sir.
Okay. Let's run this code for 40 and 19. What happened?
A floating point.
It has been truncated.
Yes, sir. We need to do
Right?
typecasting.
Yeah. So it is not the typecasting. Basically, what happens here, the average is an integer variable, and we are trying to store a float value over here. So it will only accept the integer part and it will truncate the remaining part. So just to have that effect into consideration, one can define a
Float
float
average.
variable average, and over here the format is specified as percent. Now, if I run, so what was the input? 40 and 19. Is it working? Still, I think there is a issue, huh?
We will get floating point.
Right?
29. Yes, sir.
But it's not correct.
Yes, sir.
Okay. So anyway, we will answer this, why this is not correct. But as of now, let me just write 2.0 and run this code. Now you are getting the correct output.
Yes, sir. The division operator result by default it is an integer.
Not so. We'll answer this question in the next class. So here when we'll distinguish between real arithmetic and integer arithmetic, then things will be more clear.
Okay.
Okay. So whatever we have discussed, do you have anything to ask? Please ask.
I think
Hello, sir.
sir, here I
Yes.
think in case of average equal to in what bracket is it? That's why not getting the real the right answer.
No, still it will not work. So what do you want? You want this?
Hello, sir. I do have one doubt, sir.
Yeah, tell me.
Hello.
Yes.
Sir, actually, whatever the program code that we are giving in C, that is the high level language. Is it right, sir?
Yes. Right, right.
For understanding the computer, again, we are converting the high level language into low level language by the compiler.
By the compiler, right.
And here, after executing the program, again, we will get the answer in machine language. That means in zeros and ones.
Right, right.
Will this machine level code will be converted into high level by the same compiler, sir?
No. So it will not be compiled. So see, you have to think in that way. Okay. So why you are moving towards the machine level language? Because the intention is the machine can only understand the machine level language, right?
Yes, sir.
Over here you see the output that you are able to see is not in a machine level language. It is in a high level language, right?
Yes, sir.
So this output is not because of the compiler. I mean, the compiler that has converted to the machine learning language. It is the
Yes.
code that you are writing. All these, conversion like this addition, okay, putting value over here, all those things are being done by the machine using machine level language. But the result that you are able to see because of your code which you are writing over here.
Sir, here no conversion is taking place. Actually, what we are seeing, for suppose 4 plus 2 equal to 6. 6 is the high level language, I think.
Yes, 6 is a high level language, right?
But the operations what are doing on the 4 and 2, that is in machine level language.
That is in the machine level language, right?
But here in the output screen, what we are seeing, that is the high level language code.
Yes.
Here any conversion is taking place.
No, see, okay, so okay, let me give you in that way. So see, once you have done this, so ultimately what happens? The X you are storing in your main memory. Okay,
Yes, sir.
so X will be stored in the form of 0, 1. So whatever the binary conversion corresponding to 40 will get stored in your memory. Similarly, the binary conversion for 19 will get stored in the location Y. Okay, sequence of 0, 1. Now when the CPU will fetch and decode and execute, so it will read that sequence of 0, 1 corresponding to 40 and 19. And after doing that expression addition, okay, it will store the result in the sequence of 0, 1 itself in the memory. In the AVG, it will store in the sequence of 0, 1. But now, as you are using this format specifier, okay, so that sequence of 0, 1 is being displayed to you in a decimal number.
Okay, sir. Okay.
Okay,
Means
when we'll talk about character and other things, we will also see the code. The A can be displayed as a 65 because the ASCII code for A is 65. So when we talk about a character, things will be more clear in that case.
Okay, sir. What I have understood that here only the compilation takes place at the beginning of the while we putting the high level language to low level language. Only at this stage only compilation takes place.
Right, very true.
That here the remaining task is to be done by the format specifier.
Format specifier, right?
Okay, sir.
To display the output. Okay. So
sir, one
actually,
more sir.
Yeah, please.
Sir, one more doubt also I do have, sir. Actually, what is the difference between compilation and interpretation?
So see, what happens when we talk about a compilation, it will go in one go. Whereas if you go with the interpretation, so it will anyway it will convert your code to the machine level language also, but it will do it line by line.
Okay.
Okay.
If the compilation takes place line by line, then we will call it as interpretation.
Interpreter, yeah. So some language again depends upon some language. I'm not able to give you the example as of now, but some language are compiled language, some language are interpreted language. Okay.
Python is interpreted, no, sir?
Yeah, I think so. So I have to check. Like it's a very long time I have worked with the Python, but yeah, it is most probably it is.
Okay, sir. Okay, I got
Okay.
it, sir. Thank you, sir.
So anyway, so let me just I'm stopping the session over here. So I will upload.
Sir, please share the slide.
Yeah, I will share the slide as well as the assignment also. Let me just show you the assignment. Okay, let me share the slide only for today's. Okay, there is assignment. I think in the next session we will complete it. That assignment will make you more sense. So should I share the assignment? I mean slide here only. Let me attach here itself as a file.
So you can share in group, WhatsApp group.